One of the things that we have to do occasionally is to bid a job that we're not the basis of design. In an ideal world, of course, we would love to be basis of design in all of our projects, but that's not always the case. So a lot of times we have to look at a set of plans where we're not the basis of design and match it to our equipment or the equipment that we're representing. So that's not always the easiest part. You always have to go back and look at the competitors' model numbers and kind of cross them over to our model numbers. In this video, I'm going to show you how I cross over an LG spec over to a Toshiba Carrier spec. So here on my screen, I'm just going to talk through this while I select and price up this system, so you get an idea of my thought process when I get requests like this. Right now I have a set of plans that was sent to me, and just going through a quick look, I found the schedule where all the VRF equipment is listed. I'll just usually take a quick look at where the project is located. Greenwood, California. I'm pretty sure that's up north. See the engineer is GlueMac, and we see that the equipment scheduled is LG. Looks like a good sized job. Let's find the outdoor units. So they're all right here. Looks like there are 5 outdoor units. Looking closer, there's ERVs. Looks like there are fan coils. It looks like there's ducted, cassette. I think I saw some high wall model numbers in there as well. I'll look at some of the notes. And let's see what else we can find on the schedule. Looks like there's some mini splits also. So this was what I was looking for after I saw the outdoor units. So with LG, they it's the same model number for both heat recovery and for heat pump. So just looking at the model number won't necessarily tell you if the systems that are specified are heat pump or heat recovery. So the next thing that I would look for is their branch selector box schedule. So this tells me right here that it's a heat recovery system, because if it was a heat pump, you wouldn't need these. So we know that it's a heat recovery system. Looks like for all of the systems, they are heat recovery. And after looking at that, next thing I would typically look for is to see if there are any piping diagrams, and looks like there are. So for pricing purposes, usually on this side of the sales cycle, contractors will ask for pricing pretty quickly, and usually all of us have multiple things on our plates. So the fastest way for me to price up these projects is to look for a piping diagram if they have it, and just go off of the piping diagram, because this will basically give you all the equipment on the job. Sometimes you'll see that the engineer might have thrown this together really fast, and there won't be a piping diagram, or the schedule doesn't necessarily match up with the piping diagram, or vice versa. I always like to think that if a project is laid out, and if somebody went through all the trouble of laying this out in whatever manufacturer's software, if there's a piping diagram, like, chances are somebody actually went through the process to lay this out, to talk to the engineer. This is what I want. This is how it's going to be laid out. And their software will generally generate a piping diagram. So for me, this is the fastest way to price up a project. Now, it's not always the right way. Again, usually these things are pretty time sensitive, so the fastest way to price these things up is to go off of the piping diagram. But if you have a little bit more time, another thing I would typically do is look at the floor plan and see how these are laid out. Look at all the notes that are associated with the drawings. But again, it's 11 o'clock on a Monday morning, and this is due today, so I'm just going to go ahead and go off of the piping diagram. So let's just go. I think I saw 5 systems, so There's one with its piping and wiring diagram. There's another system. That's 2. That's 3. That's the 4th one. And there's 5. So it looks like this is pretty easy for me to price up, select and price up, just going off of the piping diagram. So typically what I'll do is just, have this here so I can reference it. It looks like this is a 6-ton outdoor unit, 2 branch selector boxes or flow selector boxes, heat recovery boxes. These are 6-port, and it looks like they've got ducted cassette fan coils connected to these. So what I'm going to do now is I'm going to go in and open up my software. That was something I was working on previously, so I'm going to close that out for now and get this done. So I'm just going to keep this recording in real time so you'll see how I do this, and I'm going to talk my way through it. But this is typically what I do every time someone sends me a set of plans, and we're not basis of design, so I have to go in and figure out how do we match up, what's equivalent, and so on. So this is Toshiba Carrier's VRoom software, so I'm just going to go ahead and fill all this stuff in. You can be as thorough as you like, but usually these things are pretty time sensitive, so I'm just going to go ahead and fill in the stuff quickly. I don't know where Greenwood, California is, so I'm just going to fire up my maps program, and then Greenwood, CA. Nope, that's not it. Greenwood, California. Look at the address on the 95635. 95635. Okay. So it looks like it's in Sacramento, or it's up there by Sacramento. Yeah. Oops. Yeah, Auburn, Roseville. Yeah, so it's way out there. So as far as picking the location, this is kind of important since it will give us the design conditions. One thing I can check is look at the schedule to see if they give us that information, because then I can just plug that in. It doesn't look like they give us that on the schedule. Sometimes up here in the general notes, they'll put that information. Yeah, so it does. So see here, it says design criteria, so I can just go off of that. 9866 for outdoor. 98, and then for winter it's 26. Outdoor dry bulb, 26. That's pretty cold. And then design conditions for the indoor. So it looks like they give us different ones. So you can always override these in the individual fan coil section, but this is like a time crunch since I got to get this out today. So I'm just going to pick just some arbitrary figures that get us somewhere close. Another thing to look for is altitude. So I know this is in the foothills in the Sierra Nevada, and it shows us that the elevation is 1,500 feet. So that's important as well. The pressure, air pressure goes down as you increase the elevation. So that means the boiling point of water and all that other stuff also goes down. So it affects how you heat and cool a building as well. So after I dial all that in, it's going to ask me to select the system. I know this is heat recovery. Click OK. And then let's go check the voltage. I'm going to fly right through this, but you can always pause the video and go back. So I'm going to look at the electrical. So this is weird. It looks like there's one system that's 460 volt, and the rest are 208 3 phase. So it's always good to check the schedule. So that one is going to be 208, and the next one's going to be 460, and the rest are 208. So this one, let's see, it looks like it's a 610 072. I'll do the same for this one. And the tag is, sometimes I will, most of the times I will tag at least the outdoor units just to make it clear. But when stuff is due, I won't tag them. So it's HPA1. All right. All right, where did that system go? All right. So that's going to be HP-A1. It's going to be 610. Hit OK. If I look at, so there's going to be a Y branch, and then each goes off into its own 6-port flow selector box. So I'll go ahead. Let me go ahead and do that. Click and drag a Y branch down. Hit OK. And flow selector box. We only have 4 or 6 or single port, but in the multi-port 4 or 6. I'm going to go ahead and pick 6. And bring down another 6-port. So in the drawings, it looks like they have some piping length. So if you have the time, it's always a good idea to put those in, since if we do end up flipping this job and it comes to submittal time, they're going to need all of that. So this is where you would do it. Sometimes just for pricing purposes, just need to fly through it and just get everything selected and priced up. But if you had more time, that's where it's always a good practice to do that. So looks like these are ducted and cassette. Now I don't remember what type of ducted these are. I'm gonna guess they're medium static, but typically what I would do is just, I can't, so I'll just go to LG's website, LG HVAC, and look up that fan coil. Let's find out what type of ducted fan coil that is. So ARNU, that's Penny. That's my corgi, my office mate. She's very yappy, but she keeps me company, so I hope you don't mind that. So it's not these ones. Let me just search for it. ARNU 15.3, ARNU 15.3, SJA4, SJA4. Oh, so these are the wall-mounted ones. Okay. Okay, so it looks like they're all ductless, so that makes it easy. So I don't have to go back and forth to figure out what fan coils those are. So, okay, so 15,000 nominal wall mounted. So we probably, what do we do? So right now we are phasing into the new U series fan coils. And now this is a bug that I will probably send over to the factory. But when you first Let me show you on a brand new fan coil. So that's a cassette one. So let's find a compact cassette, compact 4-way. So when you click and drag and bring it over to your tree, even though it says phasing in, it gives you both the outgoing E series and the U series. So if I just select that one and then go back to phase in, it'll give me just the new current U series fan coils. So I will let the factory know that that's a bug. So it's kind of confusing. So we have a 5000 and a 7000. So we don't go down to a 5000 BTU cassette. So in this case, I would just go to the next size up. And then the next fan coil was a 7000. So I'll just click and drag and duplicate it on the next available branch on the flow selector box. I have another 5000, so I'm going to go ahead and select that one. And this one is a wall mounted 1 ton, so that's our high wall. Click and drag. Again, this is annoying. Where did it go? High wall. It was a 1 ton, and then a 5000. So in our case, a 7000 BTU cassette. All right. Next box, it looks almost the same. So a 5000 BTU compact cassette, and we don't have it. So I'm going to select the 7000 version. Then we have no, that's a high wall. My bad. It's 5000. I don't think we have that size. So again, we'll just go with the 7000. And then we've got 2, 3, 4 cassettes. And we don't have the 5000, so these are going to all be 7000 BTU. So let's go in. And we had the rest, and then this last one is open. So they're all going to be, in our case, 7000 BTU. 7000, select that. And then go next. Next. All right, cool. Now this last one is not going to be used, so we're just going to go ahead and add an end cap to that one. And it looks like, so one thing I always do when I start off a new project, just system check, everything looks good. Save this to where I'm going to save it, and made a folder for it called CCC Greenwood, and just save as I go. I spelled that wrong, but whatever. All right, so let's go back to the drawings, go to the next system. Well, before I do that, let's look at the wiring diagram. Looks like they have just a standard remote controller, which the software does for us automatically, and it doesn't show a central controller. Let me go look at the schedule and see if they call it out. Okay, so it looks like a distribution controller and refrigerant piping. So this, to me, this sounds like the flow selector box, and it just says provide manufacturer's control system. All right, what does that mean? I have no idea. So is there a control drawing? Doesn't look like it. Doesn't show it on that. Okay, here we go. VRF control system, residential, non-residential. Zoom in. Okay. So let's look at sequence of operations. It doesn't say. Okay, it looks like there's a different sequence for the VRF connected to the residential and then the non-residential. So this bottom one would be for commercial. So it looks like there are digital ends and analog ends that we need to somehow. So this probably does have a central controller. So that's good to know. So we'll provide a central controller. All right. Let's go to the next system. So this one's a bigger one. All right, so it looks like it's a size 288 Y branch, 4-port box, 6-port box, 6-port box. So it's pretty straightforward. All right, so let's go to our software. Right click down here, add new system, heat recovery. So this was the one, let's find out. This one was the weird one, right? 288, yep. And this one is the 460 volt. So let's select 460 and then size 288. You'll see here that there's two. One is the space saving version, the other one is the standard. I typically just go with the standard one because if you go space saving, yes, you save some space and weight on the outdoor unit, but you do lose some efficiency with the smaller chassis. There's less surface area for the outdoor coil to reject heat or absorb heat, depending on what you're doing. So that's why the efficiency goes down. So I typically, unless we really need to, I just go with the standard size outdoor unit, 288. So in our nomenclature, if you see the S after the digits that identify the nominal size, that's the space saving one. So I'm going to go with this one. It says HPC1, HP-C1. All right. Okay, go units. I'll drop the Y branches in. Okay. So what I typically like to do is I like to lay it all out first and then fill in. So I'll put the Y branches and I'll go back to refer to the drawing. And we have a 4-port box, a 6-port box, and a 6-port box. So I'll go 4, 4, and then 6, and then 6. And this is just the way my brain works. I like to lay it all out, see it all in front of me, make sure it matches up to what is on their drawings, and then just fill in the rest of the fan coils as I go. So this was a wall mounted 1 ton. You know, it's pretty straightforward. Once you get the hang of this, or once you've been doing this forever, which is what I feel like I've been doing, it's pretty straightforward. I'm just like talking to fill in time. I used to work for the LG rep, so I have some experience with their equipment. So you know, I kind of know just by looking at the model numbers. You know, I don't remember them all, but I can dig back and see. Can remember what they were, or I can just look at the drawings. You know, these are the M2 is their ducted ones. So, all right, so we got 12, 1 ton, 2 ton, 2 ton, 2 ton, 1, 2, 2, 2. So I'm gonna go down to the next box. That's a ceiling cassette, ducted, ducted, ducted. The rest are all ducted of varying sizes. So let's go in, and where's that compact cassette? That's the standard subcompact. Size 7,000 nominal. So let's get that in, and then we have 15,000 BTU, mid static, ducted. All right, next one. Now I know you folks, some of you have dual monitors, which would make this a whole lot easier. So right now I'm just tabbing back and forth between I only got one screen, and it's a laptop screen, so it's super tiny. So I have to go back and forth to reference the drawings, but I know a lot of you have dual monitors, and you know, you have the plans right here, and then your other piece of software right there. I need to invest in a bigger monitor or another monitor. I'll be so much more efficient, but you know, I'm building out my home office, so this is all I got for right now. So we don't have a nominal size 28, so I went up to size 30. So the next one is a ton and a half, 18,000 BTU. So there it is right there. Hit OK. Next one is a 3 ton. Let me double check. We'll double check this model number. I'm pretty sure that's a mid static ducted, but let's double check. ARNU 36 3 M2 3M2A4. Yeah, mid static. All right, cool. So, and then the other one is a last one on this box is a size 15. And I know when I have one right here, so I'm just gonna click and drag. Yeah, you don't have to go all the way up there. If you already have one in your system, you can just click and drag, so you don't have to go all the way up there. If you do this multiple times a day, it'll save you all that time. Will add up. So it's just the way my brain works. All right, 28. So that we're gonna have to step to size 30. That's super annoying. Hope you guys are enjoying this. I'm trying to fill up the dead the dead silence while I work here, just to give you an idea. I know I'm making this, you know, for the folks up north, just because, you know, I haven't been able to go up there and do a training for you guys, but I plan to do that one day, meet you guys in person. But yeah, aside from phone calls and emails, this is, you get to see a side of me that you all haven't seen yet. All right, 7,000 ceiling cassette. Next one is a 3.5 ton ducted. Looks like it's a mid static one as well. Yeah, so I'm just gonna do this and kind of talk to fill in dead air, since this will just be for you guys. I'm gonna make this video private. You guys can share the link, but yeah, I don't know if you guys can hear that. Our furnace is going. Today's July 17th, and we're in the middle of that heat wave, I guess. I don't know if we're up north, but down here, it's been pretty hot. I'm closer to the ocean, so we only got up to like 80s, but my garage is my office is in the garage. So it's a finished garage, but it's not that well insulated. So if our air conditioning is running, serving the inside, then that means it's warmer in here. So I have this thing right here. Right now it's 86 degrees, and I can tolerate it. The sun is no longer shining in. I've got little windows on the garage to let some light in, but also lets heat in. But yeah, the sun is not directly shining in, but I think the hottest part of in the garage, at least, is past us. So hopefully it won't get hotter than 86. Last one here is a 15. But anyways, yeah, if you can hear that, that's our furnace. Oh no, I got mixed up. This is what happens when I try to do two things at once. So I'm doing this right here. I think I was doing the other box up there. So let me just be quiet for a second and fix this. Yeah, my bad. 7, 42, 12. So it looks like I got this one wrong. So it's not too bad. It's a compact 4-way cassette, size 9000. Perfect. All right. One thing I like to do also is go up here and just kind of look at the connection ratio. Make sure that it's nothing too crazy, and looks like 109%. That's totally fine. Anything above 120, 125, I start to get worried. So I always like to check that after each system that I put together. Let's take a look at the first one. So it looks like we're at 131, which we passed the system check, but that's just something to keep in mind. I do have a lunch and learn presentation on the difference between connection ratio and building diversity and how to properly size the system. So I'll probably share that with you guys soon, or I can just send you the link. But yeah. All right. So this one is another 6-ton, but you'll see here that we go from the outdoor unit to a 8-port, there they call it branch selector, heat recovery box in the LG speak, and then they go straight through to a 3-port box. So you probably know that Toshiba Carrier does not have a pass-through box right now. And we also only go up to 6 ports on our flow selector box. So what I would do in this case, we don't have pass-through, so I'm just going to use Y branches for this system. And since we don't have an 8-port box, I'm going to split that up into 2 4-port boxes. And then this one is a 3-port, so we can use a 4-port on that one. So that one is 208, and then it's not single phase, so I'm going to use our 3-phase version. And what is the tag for this? You know, a lot of this stuff is just tedious, and I do it for you guys, make your jobs a little bit easier so I know what I'm referencing. I'll go ahead and label these. But the indoor ones, you know, I don't have all the time in the world to do that for you. Sorry to say. Let's go ahead and drag the Y branches. So in this case, I'll put the Y branch up here just to logically group. So that 8 port is going to be on its own. That 8 port, we're splitting up into 2 4s. So I'm going to do that with these right here. I could have done it the other way, but I'm going to try to keep it as close to the original layout as possible. So I'm going to say, you know, these are the 2 4 ports that will make the 8, and then I'll drag this the final 4 port. So we have all that ready there, and we'll go back to the piping diagram and start filling them in. Looks like ceiling cassettes all the way down, and this is a high wall. What is this? TUD. Let's look that up. VRNU 093 TUD 4. That model does not sound familiar to me, so I'm gonna look it up. It's a one-way cassette. Okay, that's good to know. Let's go back. All right, so all compact cassettes, they use 5,000, which we don't have, so again we'll use the 7,000. And then another one, and then another one. So it looks like there's 4 of these, so that makes our job a little bit easier. So I'm just click and drag those, and then we've got a 5. So we'll drag the 7 down, and then we have that one-way cassette, which we have right here. It was a size 9. We use the new U series, size 9. Drop that in there. Then we have the high wall, 1.5 ton. Right there. Trick it into giving us the U series, 1.5 ton. There. And that's it for that one. That one's open. And we have more ceiling cassettes. They're all going to be size 7 because we don't have a size 5. Anyways, so go ahead and fill in those 3. And looks like we're done there. And I'm going to go ahead and add end caps to fill in the other unused ports. Let's go back up. Connection ratio 121.5. I'm okay with that. System check. We're good. Hit save. All right. Now the next one. So this one looks similar. So something that I like to do is, especially for these hotels or for these apartments, a lot of the times buildings are going to be the same, and a lot of the times the VRF layouts are going to be the same. So if you notice this, you can save yourself some time and see that these are all ceiling cassettes, 555, 9. Remember that was that one-way cassette, and the 1.5 ton. It looks like this is the same as the other one. And guess what? Our lives are made easier. I'll hit duplicate, and then I'll clean this up a little bit. But it makes it super easy to lay this out because that just saves us some time. System 4, and then I'll update the tag on this. What was it called? HP E1. Hit OK, and then I think I'm gonna be super lucky because this final one looks like to be a duplicate of that other one. Nope, I was wrong. It's its own unique system, 6-ton system, so gotta build this one from scratch, so not a big deal. Add system, heat recovery, 6-port box, and then ducted, high wall, cassette, high wall, high wall. All right. Okay, so that's a 6-ton. I think it's HP-G1 for the last building. Hit OK. Six-port. And then 2-ton mid-static. Hopefully you guys can keep up at this point now as to how I do this. Just gonna fly through 1-ton high wall. This is annoying. I'm gonna have to let them know because that it's inefficient, you know. I don't know if a lot of you know, but PSG, we're a small company. We wear a lot of hats at this company, as you may or may not know. So I do this. I do lunch and learns. I put together presentations. A lot of different things. We have to do reports. So anything to make my workflow faster and easier, I am all for. So it's a 2.5-ton. So because of this, it like sucks like what, half a second. How many times do I have to do that? That will add up. So not a fan. Looks like I missed one. I did miss one. So I'm gonna drag this down here to duplicate it, and then drag this over that to duplicate that. So I fixed that. So now I'm down here. Now I got to do the last one. It is a 5,000 BTU high wall. So let's fill that in. So it looks like we're done for this at least. Hit save, system check, everything looks good. So now I'm going to provide a central controller. So we do that, go here, central controller view, double click. So the 128 is the brand new one. Go ahead and include BACnet because there is other equipment, third-party equipment on the job that we'll need to control. So we'll provide BACnet so all the equipment can communicate with each other. Add system, add all. So as you know, there's certain limitations on how many systems or fan coils you can have on a communication line of a central controller or on a central controller in total. But this one was a pretty small job, so I went ahead and added all. Hit OK. If you can't, or if the number of indoor units is too much, the software will let you know. So it's one of the nice things about software. It'll tell you when you're doing something wrong or doing something you can't do. So it looks like got all that there. System check, okay. Let's go back to design view. So let's just go through the schedule one more time to see if there's anything that we've missed. It's all pretty standard stuff. Oh, and there's all these guys here, so let's do that also. All right. As far as the fan coil notes, okay, there's a ton of notes. MERV 8 air filter, built-in pump. So our cassettes and our ducted ones do come in with built-in lift pumps. On the high static ones, the larger ones above 6 tons do not. So I didn't see any of those, so it looks like we're good there. All right, provide MERV 13 filter is note 10. So let's just see which ones are those. So just kind of glancing, I don't see any. There's one right here. Which one is that one? So that's odd. So this is a small cassette that they want a MERV 13, and I've seen other manufacturers do this where they'll specify MERV 13 even though it's overkill for a small cassette like this, just because they know other manufacturers can't do it. I know I forget which line, but we do have an accessory for the cassettes that will allow you to accept a larger, beefier filter. I don't know that off the top of my head, so I won't do the research on that now. But that's something that when I send this off to you, I'll make a note of. But typically everything else, third-party accessories, the rep or the distributor is on their own to supply that, or pass that on to their contractor. All right, now this is weird. So this looks like, so these are the outdoor units. Seems weird. So it's got multiple split system fan coil schedules. There's 2. And they've got like, all right, at least oh geez, okay. So it looks like F1, F2. Trying to figure out which okay, so there's more down here. So it looks like these 2 go together, and then these go with this. All right, so it looks like this 1.5 ton goes to that. This is their like their mini VRF. So LG makes a small 2 ton mini VRF. So it's got these 2 fan coils connected to that, and then we've got this little 9000 BTU. Okay, so okay, I've got it. So all right. So usually with these, let's do that. Let's get single phase 2 ton heat pump first. Get that out of the way. So we don't have a 2 ton, but we do have a 3 ton, and it's like it's a 15,000 and a 5,000 BTU high wall. Oh, the tag, that's what I was looking for. SSU C1. SSCU C1. Yep, okay. Let's just get these 2 fan coils. Okay, and it was a 15 and a 5. I hope. Yeah, we should be good. So we don't have a 5. This one. So it shows, yeah. So we don't have a 2-ton. You know, permanent operation below 80% is not recommended. So that's a bummer. So what I'll do for that one, so I'll remove that one. I'm just gonna use a multi-zone, a mini split multi-zone, and use a 2-ton. What was it, SSCU-C1, and do it that way. Yeah, so we don't have a 15, we do have a 1.5. Yeah, it's one of the downsides of not being basis design. We have to kind of make do with our product offering. So that works. So I did a 2-ton multi-zone mini split and added a 1.5 ton and a 1/2 ton wall mount. So that takes care of that one. Now let's do these. So these are all just 1-to-1 mini splits, 1.5 ton, 3/4 ton. Those are the outdoor units, and then this one, 2-ton. So that's pretty simple. Let's go ahead and do that real quick. Single zone, the mid tier. What was it again? 1.5 ton. So 18,000. SSFC. I'm sorry. SSCU-A1. SSCU-A1. And then a wall-mounted one. And then a 9,000 BTU ductless single zone mid-tier 9,000 SSCU F105 SSCU-F105 9,000 BTU. Okay, and then two 2-ton. I should probably take a look to see if there are multiple. Probably are. It looks, actually it might not. Let me do this real quick before I a CUF1 and a CUF2. Oops. So typically, sometimes you'll see on a schedule, especially for apartments, multifamily, hotels, if they're being served by 1-to-1 split systems, rather than making a whole schedule with like pages and pages of like the same unit, like 2-ton serving room 101, 2-ton serving room 102, and so on and so forth. You know, human beings are lazy by default. We'll just try to find shortcuts where it makes sense, and I totally get that. Sometimes you'll see on a schedule, it'll say typical of this type of floor plan or this room, and it'll just list one instance of that system, but you have to go back into the drawings and double check and make sure that it's not for multiple rooms or floor plans. And instead of being like a handful of split systems, you've got like 100 or a dozen systems that you don't account for in your pricing. So it looks like, I mean, I can easily just from looking at the schedule, it looks like they have specific areas that they're serving, but it's always good to go and check you know, how this is all laid out. So it looks like these are all laid out with their own fan coils, and and the schedules reflect it, so looks like we're good there. So this is all the public area, so let's just make sure with any of the residential. Building B. So where were those? So there's on different buildings. So it looks like we're safe. These are serving individual electrical rooms, etc., individual bathrooms. So let's just double check this one. Building F. It looks like we're okay there because it's G, A, B, C, D, E, F. So right here, that's G. G. Looks like this is F. Yeah, so it looks like we're good there. Only one of those systems, so we're good there. All right, so it looks like I'm done selecting this within VRoom. Let's just double check the notes on the mini splits. All pretty standard. Condensate pump. So those are going to be separate because of our the high walls don't have those. This one's we'll probably have to look into low ambient kit. I don't think this is something that we do here. That's not there. So that's something I would make a note of when I send it to you guys. I don't know off the top of my head how far we can do heating, 100% rated capacity of heating down to a certain temperature. I don't know if it's 17 or 32, I forget. I don't have all that stuff memorized. So that's something I would go back and check or have you guys check for me. But as far as for pricing purposes, this looks pretty much, at least on the VRF, on the equipment end, minus accessories, looks like we are good to go. Check the email. So it looks like you guys are looking for ERVs as well. So I'll go ahead and do that separately. But as far as the VRF and the ductless, looks like we're ready to go. I know that was a long video, but that was me in real time crossing over this project from LG over to Toshiba Carrier. Once you get used to looking at the different manufacturers and looking at their model numbers, you kind of get a feel for what those model numbers are. I've been fortunate enough to work with, spend some of my time with those different manufacturers, so I kind of know most of those model numbers off the top of my head, but that will come with experience. So that was just kind of a look at how I would approach tackling this LG spec. If you have any other ideas on how to cross that over, be sure to leave those in the comment section below. If you want to see more videos like this where I cross over a different manufacturer to another manufacturer, leave me a comment down below as well. And I'll see you all in the next video. Thanks.